Hey geometry students, this is Ms. Laguru again. I am recording the third and last video to the Pythagorean theorems and its converse assignment. Here we're starting off with example 4 and we're given 3 triangles and we're asked to find the missing side labeled x. In the first example, we have x as our hypotenuse. So that would be our C. Here's our A. Here's our B. We're going to plug them into the Pythagorean theorem and find x. So let's do so. So square root of 5 squared plus square root of 10 squared equals x squared. Here, when we're squaring the square root of 5 squared, it's just going to give us 5. Square root of 10 squared will just give us 10. We're going to add those two together, which is 15, equal to x squared. And then to get rid of the square, we're going to take the square root of both sides. And so therefore, our x will be square root of 15, okay, which is our final answer. In letter C, we're asked to find x. Notice that we have 2 triangles inside of a bigger triangle. We're actually just going to use half of this picture. And because the base of this triangle is 16, I'm going to say that half of it is 8. So this measure will be 8 here. And when we plug into the Pythagorean theorem, what we're going to use is going to be x squared plus 8 squared equals 6 square root of 3 squared. So let's go ahead and simplify that. This will become x squared plus 64 equals to, now multiply 6 times 6 because we're squaring the 6. We're also squaring the square root of 3 squared, right? So this will become x squared plus 64 equals 36 times 3. When we multiply 36 times 3, we're going to get 108. Okay, bring down x squared plus 64. Subtract 64 from both sides. These go away. X squared will equal 44. Take the square root of both sides. The 44 can actually be broken down to 4 times 11. The 4 breaks down to 2 times 2. So here we have a 2 repeating and an 11 that is just staying there. So when we simplify this, x is going to equal 2 square root of 11 as our final answer. Okay, so now let's take a look at example D. And with example D, we have, again, 2 triangles inside of a bigger triangle. The bases of the 2 triangles are 4 and 5. We're going to add those together. They actually equal 9. Okay, and use the Pythagorean theorem here. This happens to be the hypotenuse. So we're going to have x squared plus 6 squared equal 9 squared. Let me move this up. Which will be x squared plus 36 equals 81. We'll subtract 36 from both sides. And we will get x squared equals 45. Take the square root of both sides. The square root of 45 can actually be broken down. That's going to be 9 times 5. 9 breaks down to 3 times 3. The 3's repeat. The 5 doesn't. So x will equal 3 square root of 5 in this case. Okay, now let's see how this applies to word problems. Here we have an example 5. You draw a picture, number 1, and then number 2, solve for what the problem is asking for. So here they're describing a telephone support cable that is attached to a pole that's 18 feet high. Notice where the 18 feet high is. It's right here. So the cable is here, right? It's 32 feet long. That happens to be the hypotenuse, our C. They want to know how far from the bottom of the pole from this point does the pole, sorry, how far from the bottom of the pole does the cable attach to the ground? Okay, so we're here, the x is the base of the triangle. So when we plug that into the Pythagorean theorem, we'll have x squared plus 18 squared equals 32 squared. All right, and then we just simplify the way we normally do. All right, so let's see. Let's go ahead and multiply 18 squared. 18 times 18 is 324. So we'll have x squared plus 324 equals 1024. We'll subtract 324 from both sides and get 700. X squared is going to equal 700. We will take the square root of this, break down the 700 to 7 times 100. The 100 breaks down to 10 times 10. The 10 repeats. So we can take the 10 out. The 7 stays inside the radical. So our final answer, let's see what the units are, will be 10 root 7 feet. Now, if you wanted to convert this into a decimal, then that would be approximately 26 feet and a half, or 26.5 feet. Okay. Let's try 2 more. In part B, Tara leaned a ladder against her house. So this is her house here. The bottom of the ladder is 11 feet from the house, so we'll have 11 feet here. And the top of the ladder is 15 feet above the ground, so this will be the 15 feet. How long is the ladder? So we're looking for x, which happens to be the hypotenuse. So in this case, we're going to have 11 squared plus 15 squared equal to x squared. 11 squared is 121. 15 squared is, I'm pretty sure, 225. Let me just double check. Yes, 225 equals x squared. We're going to add 121 plus 225. That gives us 346 equal to x squared. We will take the square root of both sides, and this will give us x equals. We can go ahead and convert this into a decimal, and this would be 18.6 feet. All right. So that is how long the ladder is. The ladder is 18.6 feet long. Part C. A walkway forms one diagonal of a square playground. So here's the square, and the diagonal is this here. The walkway is 24 meters long, so that means that the 24 goes in the hypotenuse. How long are the sides of the playground? So that means since we're dealing with a square, all of the sides are equal, so we're going to label these x, okay? So that'll become x squared plus x squared equals 24 squared. Let me go ahead and plug in my laptop before it dies, and then it stops the video recording. So many cables. Here we go. Of course.